and more coatings companies are saying they have surface tolerant coatings. But the coatings are designed to stick to whatever the substrate is. They're not specifically designed to stick to the other contaminants and bit. And something usually, even if it's not a contaminant that causes a rust issue or like a salt or something like that, when you put the coating on, if the tank or the pipe just expands and contracts, what's going to happen? The coating pops off. You've created a void in there. Having a nice, clean, very angular surface with no embedment, no extra particles stuck to the surface gives the coating 100% chance to do what it says that it should do. Every class that you take, you get into the book, and there's a saying that says 80% of coating failures are due to improper surface prep. Sometimes cleaner metal than most people have ever seen, and they're a little shocked sometimes when you blast.
If you put the blasted surface from garnet and slag next to each other, what we are often doing in blast tests, the people are shocked. They didn't realize that there's so many badments usually in the surface if you blast with slags, copper slags or coal slags. And when you have GMA directly next to it, you see what is a really white blasted surface.
2 years ago, we went to the conference, and they have all the technical papers that are there, and they had the surface prep committee, and there was 5 papers. Well, 3 of the papers were on surface cleanliness and how either the abrasives or anything else could add to a contamination, and the 4th was a little more of an in-depth study on the testing of contaminants left. So 4 out of the 5 papers were about leaving things on the surface.
It's a very basic concept. Anything is there between the surface and the coating, it is dangerous for the coating. It is straight away affecting the life of the coating. And that is where SA3 surface finish is more demanding in very crucial areas where the lifespan of the paint system been demanded more than 15 years of service life. That's where SA3 finish comes.
We've done multiple studies. We've had 3 different coatings companies that we've come in. We've blasted thousands of panels, and they've taken them and done everything from the scribe testing to adhesion testing, submersion testing, bend testing, anything, any reason that a coating could fail. And it was interesting, we've tried multiple, one of the tests we did 25 different abrasives, and the inspector and the coatings company that was there was shocked when we laid 1 plate from each abrasive on the table, and they actually butted them up together, because out in the shop when they blasted the whole panel, it all looked the same. Everything was white metal. It's not just the basic coatings. It seems to be even a bigger issue with your specialty coatings, your high temp coatings, your thermal spray aluminums, any coating that you actually do adhesion testing with, or if it's any sort of structure that you know is gonna expand and contract. The coatings companies aren't gonna jump up and say, we love GMA, only use GMA, but they warranty those coatings. And when they know that you can put it on and you're not gonna have a failure, you're already starting to see them point in a direction and say, if you do this a certain way, we'll give you a 1-year warranty, but if you do it this way, you'll get a 5-year warranty. I think that in the long run, they'll have preferred products.
We have special grain tests. What is your experience with peak density?
We've done a lot of testing with it. I was looking for surface cleanliness more than anything. I was trying to figure out why some coatings would have poor pool tests. And I kept looking that it had to be clean. Well, I then went and I was using an instrument, and it also had the feature to check peak density. I had never heard of it before. And it was interesting in the variables. I started to measure it, and I was shocked at the different levels. I could have the exact same profile, but we had peak densities that were as low as 2,000. Peak density is how many peaks and valleys per square inch. And we had some that were as low as 2,000. We had some as high as 24,000. And when you change, everyone increases profile and the object of increasing the profile in your blast is to give you more surface area. Again, coatings are designed to stick to the surface. If you create more peaks and valleys and still have the same, you greatly increase it again. So all you're giving the surface more, you're giving more area of the surface for the coating to stick to. We did multiple tests. Dry testing, we saw a significant, a pretty good difference between it. The big one was when we submerged the panels. We went and submerged panels and gave them a little bit of real world, and it was night and day difference in what you saw in the pull testing. And we noticed that the ones with the higher peak density seemed to have better pull.
Right.
I mean, some with the exact same profile, we had 500 psi pull, and then the others we did 4,000 to 5,000. We had some we couldn't find a glue strong enough.
Significant, yeah.
Yep.
And it is also a kind of unfortunate situation that major contractors still are not aware with the peak density kind of terms, which is very crucial in the business. Peak density can be achieved by, having a proper size of the abrasive. That's where, we prepare the engineered blend kind of product, which literally meets specific requirements. What happens is, in the industry, garnet is available, it's available from various regions. The problem is, till today, the entire industry has been stuck with a particular size of the abrasive. What they need is, for example, let's say a 2040 size, 3060 size. However, the 2040 is so tightly packed. When I say tightly packed, it means all the particle size are super coarse particle size. Whereas if we create the blend where there is a coarse particle size, there is a proper medium particle size, there is a proper finer particle size, and it can help project to provide a proper peak density. Peak density, as Pete rightly mentioned, it's all about having a proper uniform surface. Proper uniform surface will help it to increase the surface area, and this surface area will be very useful to have the better adhesion. And better adhesion is what will guarantee the lifespan of the paint end of the day.
Yeah, one last thing on the multiple peaks, you notice increased peak density when you get into the finer product, right? Because you have more particles hitting the surface at one time. But in some of the other abrasives, when you go down to those smaller size particles, they're not strong enough, they're not tough enough and they'll break, so you won't get the minimum profile that you need. The nice thing about the garnet is it's so much harder and tougher that you can go down to the smaller particles to where you have more hitting the surface and still achieve that profile. Absolutely. And get the energy transmit that you were looking for.